Welcome back. Today we will be dealing with worded three-dimensional problems. And so looking at my screen, I've got some tips that has to do with problem solving or worded problems. And so the first dot point is drawing a diagram, the size of your fist. The reason being is that if it's the size of your fist, you'll be able to see all the information as well as be able to see all of the right angle triangles. Second dot point is label all given information from the question as well as where your right angles are. Third, work with one triangle at a time. Isolate it from the main diagram. So drawing a separate right angle triangles, if you've seen it, separate from your main diagram. And then last but not least, label all worked out information. So let's get into our example. Our example here says from a point X due south of the top of a tower, which is 150 meters tall on level ground, the angle of elevation of the top of the tower is 28 degrees. From a point Y due east of the tower, the angle of elevation of the top of the tower is 33 degrees, shown in the diagram. Calculate the distance xy to the nearest meter. Okay, so there's a lot of stuff that's going on here. And so what we're going to do is get into the habit of highlighting, underlining the important information. So we know that point X needs to be south of the top of the tower. So from the top of the tower, it must be south of it. And the tower is 150 degrees tall. Okay. And then the angle of elevation, which I'm going to highlight in a different color right here. The angle of elevation is 28 degrees. Okay. Then for the point at Y, it needs to be east of the tower. Okay. The angle of elevation should be for point Y is 33 degrees. Okay, our question is trying to ask, or what we're trying to answer, sorry, is calculate the distance xy to the nearest. So this is our condition here, right? This is our condition to the nearest meter. All right, let's start. They've given you a diagram. Okay, when it says here, which we've broken down, x due south, right, this one here, it basically means that if we saw this here at the top of the tower and we draw an X cross shape, this will be north, this will be east, west, and south. Okay, that's what it means due south or due east of the tower. So starting from the top of the tower, looking, I guess, across, that this will be north here, this will be south, west, and east. Okay. So let's get started on the question. Okay, so we've got everything here except the angle of elevation. When it talks about the angle of elevation, this is what I mean. The angle of elevation would be from the top of the tower to the ground, right? So this line over here, as well as the line from the ground. This is the angle of elevation. Okay. The angle of elevation for point X would be 28 degrees. Okay. Okay, so that's that. Then for point Y, the angle of elevation should be right here, which is 33 degrees. Okay, so we've done that. Now let's try and solve the question. We're trying to calculate the distance of xy. All right, let's see what we've got. Xy is this line here, right? One thing about this line is it's a right angle triangle. So if we were to draw it out like this, so we're isolating it, right? Where this is O, this is X, and this is Y, right? I don't know what these angles are, sorry, not angles, sides. Therefore, I can't solve what xy is. So my only option is I need to solve either xo first and then yo, or the other way around. So I'm going to just start finding what the side xo would be. Okay, so I've got here, again, isolating it again. This here is another right angle triangle. Right. So let's start. Let's isolate this triangle right here. This one here. Okay. So this here is XOT. The height of the tower is 150 meters. What we're trying to find is XO. Let's label that Z. Right, and then we know that the angle of elevation is 28 degrees. Okay, we can't use Pythagoras, so we need to use SOHCAHTOA. Okay, so I'm going to write SOHCAHTOA here, just as a little note. All right. The opposite of the angle is called the opposite side. The opposite of the right angle is called the hypotenuse. And the lucky last side is called the adjacent. Okay. And so looking at the triangle, which two information do I have? I've got information on my opposite side and my adjacent side. Therefore, I need to use TOA or tan theta. So let's start. Tan theta equals to opposite over adjacent. Once I've gotten that, let's substitute. My theta is 28. And my opposite side is 150 over Z. Okay, I need to get rid of the Z to be, I guess, equal to, because I don't like it as a denominator. These two will cancel out. What I got now is X times tan 28 equal to 150. Again, how do I make Z by itself? I need to divide tan 28 from both sides. Okay, super easy using the algebra skills here. And then what you get is 150 over tan 28. Just got to put this into the calculator. And you should get, for Z, 282.11 meters. So this is what my OX is. There you go. Okay. Now I'm going to put that back into my little main diagram or separator diagram. This is 282.11 meters. Okay, I've done that. Now what I need to do is I need to find this one here. I need to find what OY is. So let's do that. It's another right angle triangle. Okay, so it should be TOY. This here is 33 degrees. This should be 150 meters. Okay. And I need to find what OY is. Let's make it as a W. Okay. Using SOHCAHTOA, the opposite of the right angle is a hypotenuse. The opposite of the angle is called the opposite side. And the lucky last is the adjacent. This seems like the exact same as our first right angle triangle, meaning that we use tan, right? We use tan. So it's tan theta equal to O over A. If it makes it hard for you, just write down SOHCAHTOA. Identify which one you need to use, and then write it down. Tan theta is 33 equal to, my opposite is 150 over W. Do the exact same. Make sure that the W is not in the denominator. So I'm going to cancel this out. I'm left with W times tan 33 equals 150. How do I get W by itself? Just like this. Well, I'm going to divide it by tan 33 on both sides. Right, these will cancel out. And I get, in the calculator, 230.89 meters. Okay, this is all I need to put into the calculator. This up here, on this side. That's the only part I need to put in the calculator. Right, I found my W or my OY. So I'm going to put it into my separate diagram. This is 230.98 meters. Okay, I found my OX as well as my OY. Therefore, then I can use, or I can find my XY. So let's write it. So this here is my diagram. It's not perfect, but whatever. X, Y. I know that this one here is 282.11. So there's 230.89. Let's call this one T. XY equals to T. All right. This looks like it's a Pythagoras theorem, right? No degrees, no nothing. So I'm going to write down C squared equals A squared plus B squared equals to T squared, which equals to XY. So T squared equal to 282.11 squared plus 230.89 squared. Put that into the calculator and you should get 132,937.8125 equals to T squared. How do I get rid of the squared? I square root on both sides. Okay, these will cancel out. Then what you will get equals 2. So T equals 2, put into a calculator, should be 365 meters. Okay, so that is what my XY equals to. All right, that ends our video today. So I'll see you next time. Bye.